So our warm-up question says, use the VT graph to answer the questions that follow. Yesterday you had notes on velocity time graphs because we already talked about speed and velocity, and so there was just a little extra piece yesterday in the video. By the way, if you did not, or if you need to go back and look at that video again, it is in the notes folder. I know that it was playing up here for you guys, but it is online in the notes folder. It's my notes from last year, but it's exactly the same as the slides I had this year. I didn't change it. So you should be able to go back and look at that if you need to, but I'm hoping that it made sense and that you don't really have a lot of questions. But a velocity time graph is similar to a position time graph in that we are plotting one of these properties of motion against time. But in this case, we're going to plot the velocity of the object versus the time instead of the position. But just like with a position time graph where the slope and the area have meaning, the same is true with a velocity time graph. And that's kind of what we're getting at with this warm-up question. So the first one says, what is the total distance traveled by this object? Can anybody tell me how we would find distance from this type of graph? Ava?
Find the area under the curve that's between the x-axis and the graph. Perfect.
Okay, find the area under the curve. I know this isn't a curve, but you're going to find the area under the graph. And when we say find the area, and she said this as well, we mean that you're trying to find the area between the x-axis and wherever your data points are. Okay, so I have here a velocity initially of -9 meters per second for 5 seconds. If you go -9 meters per second for 5 seconds, you're going to have traveled 45 meters. Okay, just logically you should be able to figure that out as well, but mathematically that's the area of that rectangle. And so what you're doing is you're multiplying your x-axis times your y-axis, okay, at those points. So at this point, at 5, I'm multiplying the time times the velocity. That's my x times my y. And if you think about it mathematically, we know that velocity is displacement over time. And so if I want to multiply velocity times time, that's the same thing as rearranging that equation and saying, well, if velocity is displacement over time, then velocity times time is displacement. That's why you're finding the area. Mathematically, it's the same thing as that equation. So if you go 9 meters per second backwards for 5 seconds, you will go 45 meters backwards. Now, I don't care about the backwards because it says total distance. Distance doesn't have a direction. I'm just going to take all of my motion and add it together. So this is 45 meters. So is this. This rectangle right here, not the whole thing. This is like an L. That's not a normal shape. You have to break it into normal shapes. But from 5 to 10 seconds, that's 5 seconds of time that has lapsed, and you go 9 meters per second forward. So if you go 9 meters per second for 5 seconds, that is also 45 meters. And then you have this little rectangle here. 5 seconds at 3 meters per second, you're going to go 15 meters. So 45 plus 45 is 90, plus 15 more is 105 meters. That should be your total distance traveled by this object. Okay, and that is the area under the curve. Any questions about number 1?
I don't understand it.
Do you have a specific question about it?
I just don't understand I got 105. I got the velocity graph.
It's different than the other ones. You find the area of this, the area of this, and the area of that. So it's like
this is only like 20.
All right, look, I can look at that more specifically with you if you don't have a specific question about it. Okay. Does anybody have a question about that one, like specifically, other than I don't get it? That's just not a specific question. I'd be happy to help you with it though. Yes, sir.
Okay, so if you're going -9, so you're going backwards 9 meters,
Yeah,
right?
that's all the negative means.
For 5 seconds.
Mm-hmm.
Do you mind
Like-
explaining where you got 45 from now?
If 9 times, okay, if you go, let's use some easier numbers for a second. Let's say you travel 1 meter per second for 5 seconds, right? Let's use some numbers that we can think about really easy. If I travel for 5 seconds at 1 meter per second, how far am I going to go? 5 meters. Like, hopefully that just logically makes sense to you. Okay, and that you're not having to even do math. There's no area there. Just if I go 1 meter per second for 5 seconds, I'm going to go 5 meters. Because after 1 second, it's 1 meter, and then 2, and then 3, and then 4, and then 5, right?
You're not going 9 meters in 5 seconds. you're going 9 meters per second.
Correct. I am not going 9 meters in 5 seconds. I am going 9 meters per second for a total of 5 seconds. So if I'm going 9 meters every second, then after the first second, I'll have gone 9 meters. After the next second, I'll have gone 18. After the next, it'll be 27. Does that make sense? Okay, and so that's where we're getting 45 from. But it also happens to correspond to the area of the rectangle. Okay, so if you have a VT graph, you can find the area, and that's the same process. It's a little bit of a shortcut. Okay, any other questions about number 1? Okay, number 2, which is greater, distance or displacement? Why do you say that, Peyton?
Displacement is only 9. Is that right?
The displacement, what is the displacement?
The distance from
No, sorry, I don't mean definition. In this question, anybody know what the displacement is? Remember, this right here means I'm going backwards. If I go negative 9 meters per second, I'm going backwards 45 meters, and then I go forward 45 meters. That means I'm back where I started after 10 seconds. But then I go a little bit further, right? And so my displacement would only be 15 meters. It's just this one. If I go 45 meters backward, and then 45 meters forward, and then 15 more meters forward, then my displacement's only 15 meters.
Oh, because it's different than the other graph.
Yep. Okay, so my distance, and again, I've said this already, but I'll say it again. Your distance is always going to be either greater than or equal to your displacement. Okay, because your distance is the whole path you travel, whereas your displacement is just how far you are from where you started. So when you backtrack, your displacement is going to be smaller because you're canceling out some of that motion. You're going back where you started. In this case, he goes back where he started and then past it by 15 meters. Okay, so again, that as a general rule, your distance is always greater than or equal to displacement. The only I said that. Yeah, that's right. The only reason they're going to be equal is if my motion had all been forward. Okay, if I get rid of the first 5 seconds and just look at the part that looks like an L, they would have been equal to each other because all of my motion would have been forward. And then if I'm just going forward in a straight line, then they're going to be the same. All right. Hopefully that made sense. If you guys have questions, more specific questions about about speed and velocity, or specifically velocity time graphs, obviously you can ask me today as you are working. Or you can go back and look at the video again, or just my notes. You can go through the slides. Today we are going to work on this assignment 108, mixed practice CFU/quiz. I say quiz, it's not really a quiz because you're going to use your notes. I don't even care if you work with each other on this, but I say quiz because the way it's scored. Okay, it is a CFU in my open math. Whenever I assign it as a CFU specifically, I am turning off the partial credit that you normally get. Okay, that's what I mean whenever I say it's kind of like a quiz. So it's graded more like a normal quiz would be. If you get it wrong the first time, you don't get the points. However, it is still set up so you can do it again for practice, but you're not going to get points for it unless you get it right the first time. Okay, so I need you guys to go ahead and make your way to My Open Math. We are not spending the whole period on this. If you happen to have already completed it, I have some students that are working ahead, and that is perfectly fine. If that applies to you, then you are welcome to head to Schoology and open up the Unit 1 summary, because I did put that in there. I've talked about that a little bit, but I'll talk about it after this. The rest of you, if you haven't done this yet, you need to go ahead and open up 108 Mixed Practice CFU. You are welcome to work with each other. That is perfectly fine. However, again, it's not going to give you credit if you don't get it right the first time. Please read the directions in the question, okay? And the directions for the assignment. They typically say round to 2 decimal places unless I tell you otherwise. So make sure you check that so that you're not missing points for rounding. Or make sure you check it for units or whatever else, because I have tried to be very clear and I typed in the directions. If you miss it for something that's in my directions, I am not going to give you partial credit. Now, if you miss it for something that was not in my directions and it wasn't clear, you can ask me about it. Okay, but I don't think there's going to be anything like that. I will say this, I do know somebody last period had a situation where I think the displacement that they ended up with was 0, like their particular scenario that ended up where they started, and it was taking points off because they did not indicate a direction. It's not supposed to have a direction if it's 0, so if that happens to you, please let me know. I'll add the points back on. Okay, but again, since they're random, I don't know that that'll happen to anybody, but if it does. Otherwise, if you have any other questions, let me know or talk to your neighbors. Go ahead and work on this, and then for the latter part of the period, we're going to talk about our relevant application for Unit 1.
I have a question about, there's no nano one here.
But I have a couple of other things we need to discuss. One of them is the RA that we're about to start, but I do want to show you one other thing first. So I've mentioned this a couple times now. I'm going to show you Schoology real quick. Bless you. In Schoology, I have now added the unit summary. So when you log in, it's the first thing that you see in the constant velocity folder. When you click on it, I clicked on it earlier. You can open up your own document. So it looks like this if it decides to load today. But you're going to see a Google Sheet. You're welcome to open it with me and look at it with me if you like. There is a spot for you to type in your student ID number in the kind of upper left-hand corner. Mine is moving really slow, guys, so hopefully y'all's is faster than mine is being right now. But there's a spot for you to type in your ID number. When you do that, I don't even know what it's doing, but when you do that, it will automatically fill in your name and your class period, and it should show that you're in K. It'll fill it in for you. So type in your ID, and it should fill all of that in for you. You have to do that first because if you don't have your ID typed in, by the way, there are tabs at the bottom. This is where you'll find the questions. I clicked on the dimensional analysis tab. Some of you are having trouble with your conversions, so there is some practice in here. And there's an example, but you'll notice that there aren't any numbers in here right now, and that's because I haven't typed an ID number in. So your first thing that you're going to do before you do anything else is on that first tab that says score, you need to type in your student ID number and then press enter, and it should automatically fill in your name, and it's going to then randomize the numbers in the sheet based on your ID number. So you're not going to have the same numbers as your neighbor in all likelihood. It's possible, because on this sheet, this is one of the first ones I made. I randomized, I've been doing this for a while, but whenever I programmed this one, I think I only had like 10 versions, but the newer ones have like 81. So you might have something similar to somebody, but most of you are going to have different versions of this. But you'll notice this one tells me to convert 1,410 millimeters to meters. So if I put in my answer, which I know is 1.41, okay, it tells me show your work. Okay, so it's actually going to make you type your work in over here. So let me go ahead and put my work in. So I'm going to say 1,410 millimeters, and then my conversion factor, there are 1,000 millimeters in 1 meter, and then I can put my answer in 1.41, and now it will tell me that I'm correct, and it will automatically update the score at the top. So now I have 20% of the points on this page because there's only 5 questions. If you get the answer wrong, just completely wrong, it'll tell you that it's incorrect, and you'll notice I did not get points for that. Okay, so it will automatically give you feedback on if you're right or wrong, and then you can fix it obviously without losing any points. So it's kind of just a good practice sheet for you guys to go through. And again, it's going to update your score. You'll notice on this first tab, actually let me put the right answer back in for a second so I can show you. 1.41. You'll notice on this first tab that it automatically calculates my score on the whole sheet. Well, the whole sheet's out of 129 points, so right now I have a 0.78 as a grade because I've only answered one question. It also has another column that says bonus. You are going to be able to complete this for bonus points on your test. It is going to be up to 5 points. The way that we're calculating the bonus is by taking the score that you earn here and dividing it by 20. So if you get 100, that gives you 5 points. If you get a 90, 4.5. If you get an 80, 4 points, so on and so forth. So you can earn bonus points for your test by completing this. It is also, according to your syllabus, which I'm hoping you guys all got signed online and with your parents, according to your syllabus, the unit summary is also your daily grade redo. So if you end up with a failing daily grade and you want to redo on it, you actually don't redo the same assignment, you do this instead, and it will be a redo because this covers the whole unit. So there are tabs at the bottom for dimensional analysis, for distance versus displacement, for representations of motion, proportional reasoning, and speed and velocity. Okay, so again, this is optional. It's not a grade by itself, but if you choose to do it for the bonus or for the review, I would recommend it. Yes, ma'am.
Could you help us with it or no?
Yeah, if you have questions about it as you're working. We don't really have a ton of time in class. I know some people work ahead, so they may have more time to work on it in class, but you'll have time here and there where you can work on it in the room with me. Otherwise, you're welcome to come into tutorials and work on it there if you want to work on it with me. But yes, you're welcome to ask questions as you work. The other thing in Schoology that we need to talk about today is the toy car RA. If you're looking in Schoology, it is assignment 109. This is what we are going to be working on today. You should have a doc in there, but I forgot to attach it first period, so I need to check and see if y'all's is attached. It might not be, in which case I need to attach it. I thought I did that. But it's going to give you your own document that you can type in. And so this is, again, it's being slow. This is what that document looks like. And what you're working on today, and I'll put it up on the slide in a minute, is this procedure section. And then maybe these pre-lab questions would be good as well, but you have to do the procedure section first. But let me go back to my notes real quick. It says, your task is to determine the speed of a toy car and whether it travels at a constant speed. The materials that I'm going to give you are the car itself, which is going to look like this one. Okay, I'll show you, they're battery powered. Well, something like that, but that's what it does. Okay, so you're going to get this, a meter stick, and you may use your phone for this RA as a stopwatch. Okay, so we don't use our phones much, but you'll be able to use it here. So right now, I would like you guys, first of all, to get into groups of 3 or 4, which could be the people you're sitting with. It is up to you, but y'all are already sitting in groups of 3 or 4. And I would like you to brainstorm ideas to answer how you might actually test this. What can you measure? How could you do it? How could you figure out the speed of this car? Take a moment, turn and talk to the people you're sitting with, and see if you can come up with an idea or two on how to go about doing this. And then we'll share those and talk about what we're doing, and then you guys are going to be writing out some procedure steps in a moment. All right, guys, we need to talk about some of your ideas. I'll have to look at that in a second. Yeah. So, guys, what did you guys come up with? How can we test this? What can we measure? Scarlett. Okay, so you're going to measure meters and seconds. Yeah. I'm assuming. Okay. So she said she's going to use the meter stick and a timer to measure how far it's going in a certain amount of time. Is that what you're talking about doing? Okay. Did you have something different? Same thing? I mean, that's what I assumed you guys would come up with. What can we measure? We are able to measure both the distance that it travels using a meter stick and the time that it takes using a stopwatch based on the tools that I just gave you. Okay, and so you can measure distance and time, and with that information, yes, you can calculate your speed or your velocity. These cars hopefully go in a straight line. I say hopefully because sometimes they aren't perfect. But hopefully they're going in a straight line, so you should be able to get speed and velocity here be the same thing basically in terms of the magnitude. But that is what you're going to be measuring. Okay, so you're going to choose how you want to test it. You guys, it is your responsibility to come up with a set of procedures that you're going to follow. So how exactly are you going to do this? Okay, you need to have at least 5 data points, but it says here to choose the variable you wish to test. I mean, y'all probably all came up with the same thing. I didn't hear any other answers for the last one, which is, I mean, it's what I'm expecting you to come up with. But to determine how the time traveled affects the distance that it moves. So maybe you said, you're going to, do it 1 second, 2 seconds, whatever increments you choose. But you need to write that out in a list of procedures. Okay. just thinking about this, if you're testing how the time is going to affect how far it goes, which is basically what you're looking at when you're looking at speed here, can you test them on different surfaces? Can you do some in the room and some in the hall?
Yes.
No, you can't have that more than one.
Yeah, you cannot have more than one variable. So you are going to want to make sure that you control for some things like that. And so you'll want to include maybe things like that in there as well. That one's pretty obvious, but whatever other little details, you know, that you might need in order to make sure you get valid results. Okay, so that's what you guys are doing right now. Clearly state your steps so anyone can follow them. Okay, you're going to write out your procedure just like you had to do for the spaghetti bridge, and you're going to do that in the Schoology assignment, which I am uploading right now. Clicking save. It finally loaded. So you should be able to, you might have to refresh your screen if you're already on the assignment. It still says loading. Or you may have to head there. If you're heading there now, hopefully it's there. It looks like it's done. It's in there now. So if you refresh, you should be able to open it. But guys, you need to come up with some procedures because you are doing this lab. Whatever lab you write, you're going to be doing whenever you come into class on Tuesday. Okay, so I need you guys to write some procedures out. If we run out of time and you don't have enough time to get the whole list, then your homework is going to be, I did not mean to turn that on. Your homework is going to be to write some procedures on your own, and then on Tuesday when you come in, we don't have school Monday, but on Tuesday when you come in, you can then discuss with your group really quickly and say, okay, let's make sure we all agree on what we're going to do, and y'all can modify if necessary so y'all have the same thing. Okay, but that's your job right now for the rest of the period, is to come up with some procedures, and you can type them in the doc on Schoology. If you have any questions as you are working, you can let me know. Otherwise, you'll be doing this on Tuesday next week.